Welcome to the channel. I'm Carlos Ortega, and I'm excited to explore the amazing worlds of physics and chemistry with you.
Look around, and you will notice that everything is in a state of flux. From massive planetary bodies in orbit to the terrestrial landscapes beneath our feet, the physical world is defined by constant change. These shifts do not happen in a vacuum. Any physical transition requires that the objects involved possess the ability to undergo change. Scientists quantify this ability as energy. It is present in all objects, and the more energy an object possesses, the greater the change it can experience or cause in its environment. To understand the mechanics of our universe, we have to track how this energy manifests, how it moves between objects, and how it transforms from one type to another. The most immediate and observable manifestation is the energy of physical motion. The Voyager 1 space probe has a mass of 720 kilograms and travels at roughly 60,000 kilometers per hour. Because it is moving at such a high speed relative to other objects, it carries a vast amount of motion energy. This principle scales down to the biological world. When a cheetah sprints across a field, its movement is a direct result of this same energy type. This is scientifically classified as kinetic energy. An object's kinetic energy is proportional to its mass multiplied by the square of its instantaneous speed. While its mass remains constant, even a small increase in speed results in a significantly larger amount of kinetic energy. Kinetic energy is tied strictly to movement. If an object stops, its kinetic energy reaches zero, leading to the question of what happens to that energy when the motion ends. While motion is easy to see, energy can also be present in objects that are completely still. At the very top of a roller coaster, the car may pause for a moment of zero speed. Although its kinetic energy has vanished, it sits at a point of high gravitational potential. This height-dependent state is known as gravitational potential energy. We calculate this by multiplying the object's mass, its height from the ground, and the acceleration due to gravity, which is 9.8 meters per second squared. In this state, height functions like a reservoir. The further an object is lifted from the ground, the more potential energy it stores to use in a future transformation. And as the roller coaster car tips over the peak, that stored energy begins to change form immediately. As the car loses altitude, its gravitational potential energy decreases. Simultaneously, the car accelerates. The kinetic energy increases in direct proportion to the potential energy being lost during the descent. The descending car shows this exchange in real time, reaching its maximum kinetic energy at the lowest point of the track, where speed is highest. The sum of an object's kinetic and potential energy at any given moment is called its mechanical energy. In a frictionless environment, this total would remain constant, with energy simply cycling back and forth between speed and altitude. If the exchange between potential and kinetic energy were perfectly efficient, a moving system could cycle forever. However, we know that a dropped ball will bounce lower and lower with each strike, until it eventually comes to a rest on the floor. This gradual loss of height occurs because of friction. As an object moves through the air or across a surface, friction forces it to transfer a portion of its mechanical energy to its surroundings. This energy is not destroyed. Instead, it is transformed into less useful forms, primarily heat, or thermal energy, and sound. When an object stops, its mechanical energy has simply degraded and been absorbed by the environment. This brings us to the law of conservation of energy. Energy cannot be created or destroyed. The total amount of energy in the universe remains constant. Every physical event, from a rolling ball to a star, is simply a process of transferring energy from one object to another, or transforming it from one type to another. Even the massive outputs of the sun follow this rule. Inside, nuclear reactions convert nuclear energy into radiant and thermal energy, which travels across space. The universe functions as a system where energy is always changing its form or its location, but is never lost.